Okay, so it's recording now. So anything you say, it'll be recorded on here. It won't be shared to anybody in the class, so you can say whatever you want. And then I'm just sending you just the link, by just to you in your email address. hmm So for this problem here, I know the problem in my MyFuss Plus. It says use the Gaussian-Jordan elimination method. We're not doing that. If you have viewed my slides before, we're not doing any of this kind of method because if you look at the viewing example and the way they do it, it's just too much to do all this other stuff. So we're not doing that method at all. All I told you to do for this one is there's an elimination method that I showed you. And I want you to use that elimination to practice these problems in here. So just don't even worry about whatever here. When it says this, just do the elimination method. Does that make sense? Uh-huh. Oh, right. So for that one there, that's what I'm going to actually go over on tomorrow's live session is I'm going to go over the REF because you can actually solve a lot of these problems with just your calculator, but that does not show work. The lab that I gave you in Moodle, have you looked at the lab in Moodle yet? Okay, so with that one, I'm assuming since you already completed it, I'm assuming you did everything RREF. Yeah, so anybody that sends me, uh-huh. Right. Okay, good. Then that's what I'm saying. That's what I'm trying to tell everybody in the class that if you just did RREF for all, now you can do it for checking your work. Now, if you want to check your problems, you can do the RREF, but if you don't show me that work, I'm not grading it. That's what I told the class. Yeah, so that's the only part about that one. Yeah, just for that lab. Yes. So on a test or per se, if the test says use the elimination method or if it says use the substitution method, I do need to see it, and I'm going to put in like a separate link for you to upload that particular problem on the test. But if it don't say anything, if it says like Gaussian or something, you can use any method that you want to calculate or whatever, and provide your answer. So let me see if I can show you an example of one that's So all these, if this said this on the test, you can use the calculator, the REF. I'm explaining this again on tomorrow, or during our class. I don't have any problems with that on the test, but I'm telling you to do the elimination method so you can just practice on how to do it. Yeah, 9.3 is fine. Because actually, the only thing you needed to do in for homework, I think only anything is just 9.1 and 9.2. I think 3 is not due to tomorrow. But you're more than welcome to work on it. So let me go back to 9.2 real quick. So for this number one here, it says solve the system of equation. It does not show, it's not tell you if this was a question on the test, it's not tell you to do substitution elimination. You can do any method that you want to. So all these says solve doing the yeah, this one says solve using the following equations. So all this stuff here, I'm not requiring any work shown. So that's for 9.2. Yeah, I'm trying to fix. Yeah, let me look at this real quick. All right, see how it says solve by substitution method? This right here is going to be a problem that I need you to write down on your paper, take a picture, and then upload it in Moodle because on the test, it might say that you have it right, but until I look at your work, this one is actually marked wrong. Like you're not going to get credit. Yeah, you're not going to get credit for it until here. This one right here says solved by the what? That's what I need to see the work. So there's two things just so I can repeat. If it says the that the elimination method with that Gauss elimination method, whatever how we pronounce that, I need to see work. In section 2, it said just solve the equation. I don't need to see anything for that. You can use RREF if you want to. For checking, if you want to check your work at the end. So I need to see the work, but then when you get your final answer, if you want to use RREF to check to see to make sure that's right during the test, I have no problems with that. But on the test though, I need to see the work laid out for those particular for certain problems. So let's go back to 9.3. And if I did, I'm sorry for the confusion, but um this one here. So this one here, I need to see the elimination method. Now, if I said it before, I'm sorry, I got confused or whatever, but because it said this method here, this is what I actually need to see the work on the test. And like I said, if you want to use RREF to check the work to put it into the answer, I have no problem with that, but I'm not counting it right until I see the work for elimination method. Yes, uh-huh. You want me to go back to it? And I'm gonna lay all this out in Moodle so everybody can make sure they understand. Okay, like this one. Correct, correct, correct. So just like let me see if I can bring this up real quick. Exactly. Well, yeah, that those. I mean, it's just it takes multiple steps, and like I said, if you're not careful in each one of your steps, one little slip up with adding, subtracting, or multiplying, then the whole problem gets thrown off. Which yes, it can be frustrating, but that's what I said in the other video. Is once you slip up and not get the right answer, don't erase all your work. Just take out another sheet of paper and try it again because it can be just a simple addition or subtraction slip up that's causing the whole problem to be thrown off. And like I said, there's nothing really I can teach you on that part. All I can teach you is how to do the LCD like you just said, eliminate one of the variables and go from there. That's what this section is about. So right here in this slide here, and this is what I'm going to go over here. Any directions asking for this right here, I want you don't worry about this process. This process is very confusing. If you look at viewing example, it's really confusing how to do it. So I just want you to use the elimination method taught in section 9.2. Then you can check your answers using the calculator. So on the test, if it has its directions, I need to see the work using the elimination method, but you are allowed to check your work using the calculator. Does that make sense? Okay. Okay, let's do an example of that one then. Um, it's different concepts, but I mean to get to the answer, yes, but the process is different. You don't want to do substitution method with a three because that's just way too complicated. It can be done, but it's just way too many steps and complication going on with the problem. Right, exactly. You just want to do that with two letters. Like anytime it says substitution, more than likely it's just going to have two letters. Yeah, that's it. That's the only time it really will actually do substitution. Everything else should be elimination. Within the process, yes. If you always start off with if you have three letters, you're going to start off with doing elimination. You have no choice. You have to do elimination. But when we get down to the end, there's going to be a specific look of the problem that you have to do substitution. Yeah, you plug in, but it has to look a certain way. And I'm about to show you what this problem of what it should look like. hmm Elimination is always with three. So if you want to write it off to the side, anytime you have three letters, do elimination. Don't do substitution unless the I'll show you when to do substitution at the end. So we're going to label this on one. I told you before, always label your equations because like I said, it'll get messy. Um it'll get messy towards the end if you don't label these equations. All right, so you see are you finished copying the problem? Okay. So with this problem here, we're just kind of figure out what you want to try to eliminate first. Like I told you before, it does not matter. You can eliminate the y's, the z's, the x's. It does not matter. I would just suggest you always try to eliminate the easiest one, pretty much without numbers in front. So this one has a 4. This one has an 8, a -8. So these have just x's. So that's probably what I want to start off with first. Does that make sense? Yeah. So I'm gonna take 1 and 2 and try to eliminate the x's together. And the only way for me to eliminate the x's is that one of these has to be a positive and one of them has to be a negative. So if I multiply the second one by -1, that will go in and actually change all the signs in the problem. Do you agree? Okay, so let's write the first one. And this is equation 1. And then I'm going to write the second one. This time I'm going to actually change all the signs by multiplying, distribute this -1 inside. So that becomes a positive. This becomes a -4y, a positive 8z, and a positive 22. Correct. So now I'm ready to add them together because I know now my x's is going to do what? they cancel. That's what you're looking for to make sure whenever you multiply a number in, just make sure you do that so something can cancel out. That's the reason why I was doing like the LCD or LCM, just because we want something to cancel out. Does that make sense? Exactly. And if you did that, you get the exact same answer at the end. It's up to you. If it's up to you, if you want to keep writing it down, that's fine. Or if you want to show that you did -1, I'm limited on space on my screen because I don't have a piece of paper that I can keep going, so I have to kind of do a little bit of shortcuts. But it's up to you as far as to when you show work on your paper. Hmm. Correct. You have to. It's no getting around with it. If you use 1 and 2, you have to use a different set. It has to be 1 and 3 or 2 and 3. It's up to you which ones two you use, but you have to do a different set of no equations on the next go around. You got to do the x again. That's right. Yeah, I would suggest you do stick with the 1 and 3 going because the reason why if I look at one, there's no number in front of this one and this one and this one. So when I start multiplying stuff in, it's less work. Now, if you do -6, wouldn't that change that to a +6? See, I would suggest you do a 6 and then add it. Now, if you do the negative, that's fine. You just got to come back and now subtract the two equations. But if you do -6 to everything, then +6 to everything, then you can come back and add the equations. Does that make sense? Uh-huh. See how easy that was to choose the first equation? It was 6, 6, 6, 6, and then 24. Because if you had to do it to like the last one, something you had to do a lot of multiplication. Yes. And then now this one here is going to be labeled to be number 4 equation. And then this one here, since I created a new equation, will be number 5 equation. When you add or subtract these two equations and you create another one, you need to put a new number to it. Yep, on top of each other. So I'm going to go ahead and write this other one here. I have -3 plus 9z equals to 18. So this is equation number 4. I'm sorry, let me make it a little clearer. So this one here is 5, and this one here is 4. Does that make sense? It don't, because we're adding. If we do 5 plus 4, that's 20. I'm sorry, 9. And if I do 4 plus 5, that's still 9. So if it doesn't matter if we flip flop it. No, no, no. Stop. Look at the equations. 4 and 5. You looking at 4 and 5? No, no, no. But listen, listen. Well, you have equation 4 and 5, right? Remember, our goal is to, again, we're still trying to eliminate a variable, just like we did here and just like we did here. If we add these two together, is any one of these variables going to be eliminated? That's when you have to do the LCD. So that's when you need to write down again the LCD, because we have to try to get rid of a variable. So what do we need? What are we trying to look? What variable are we trying to eliminate now? We're going to do the Y's. Okay, so it looks like, yeah, 12 would be the LCD. So we got to multiply the top one by what? +3, and then +4 for the bottom, right? That's right. So since this first one right here, you see where I'm circling that? This one's already positive. I'm just going to multiply by a +3. Correct. No, a +4. Remember, it's already negative in front. You see this negative sign in front? There's no need for us to change any signs because they're going to cancel out anyway. So why do you think you did something wrong? Again, when you're doing these problems here, there are times when it's going to be that way. If you did all your math correctly, you got to stop thinking you did something wrong. Nope, that's not this what this means. Back in the other slides, I told you if it equals the same thing, it's going to be infinite many solutions. When it's no solution, if I had 10 on this side and it says equal to 5, 10 cannot equal 5. So this right here would be no solution. So this is the part here in my other videos when I told you to, if you get infinite amount of solutions as an answer, this is where you need to say, tell yourself, I need to do more work. This is where substitution comes into play. No, this is part of the answer. No, because in the problem, and I'll show you in the problem, you have part A where it says there is a solution. That means you get an answer. You put it in this box. Part B says, is there infinite amount of solutions? Well, if it is, which we just proved it, we have to find out what the equation should be that goes here. If it says no, if there's no solution, then we click here and we're done. Right. So we got to keep going. That's why I put up here, you need to do more work. Use the substitution method now. So let me for this one here, when we get down to here, this is when we take either equation the equation 5 or 4, it does not matter which one you take, and solve for a letter. I'm gonna go ahead and solve for y in this case. They're both the same, right? Do you remember what the original 4 and 5 was? I think it was right. So take the original one of those two, does not matter which one, and we're gonna solve for y. I'm just gonna go ahead and take 4. And let's solve for y, get y by itself. So I'm gonna move this over. Oops, wait a minute. Mm-hmm. Yeah, it's the same thing. Remember we taught you it's the same thing, right? Yes. Yeah, you can. That's fine. So we combine like terms, and we're going to solve for z in this case. I'm sorry, we're solving for x. I'm sorry, we're solving for x. Where you lost that? Yep. Uh-huh. Mm-hmm. Yeah, we're trying to get X. We're trying to solve for X. Yeah, this is we you got to keep this negative in front. So I brought this negative down here, here, and here, right? Because this is where the negative came from up here. What happened? Can you see that? Okay. So this negative up here, that has to go for this X and this X here. So once I do the equation, I brought the positive 6 over. That gave me positive 2. I subtracted the minus 4z here. These cancel. I brought it over here and I put it down on the back part. So I have 2 minus 4z. Okay, yeah, that's over here. So if you want to change it around, that's fine. 4z minus 2, that's fine. No, that's it. Okay, so the ultimate goal for these problems is when you put it into the answer, I need an x, comma, I need a y, comma, and I need a z. I need an answer here, here, and here. Does that make sense? So here, I need an x. I just proved my x here. So down here, you put 4z minus 2. Comma, what's my y? Well, down here, we solve for y. So you put minus 6 plus 3z. Now for z, because z is actually in this problem here and this one here, this is where we can just write down the answer z for the last part. So basically whatever letter that we have in both of these equations, we just write the letter here. So if this was a y and this is a y, over here I'm just gonna put y. So say that this one was 4y and this one here had a y in it, then I'm just gonna write y as my final answer. But because they have a z here, a z here, I'm just writing z for my final answer here. Yes, yes, Kim. So right now, again, yes, there's a lot of work in here, but from start to finish, do you understand the process? Now, do you talking about one that has an infinite amount of solution as an answer, or it doesn't matter? You just want to do the whole process? Or equation. So it has to be the infinite amount of one. I don't know. Yeah, it is the same thing. It's just with the when you get, like I said, when you get down to the end and you have, 0 equals 0, it's just when you have to take the equation 4 and 5 and just solve for one of the letters. And that creates this equation here. And then you sub this equation back into the equation here and then get the other letter, which is x. And then combine like terms. Yeah. I think, like I said, the confusion part just comes in when you're working one of these problems. And I think when you got confused, right in here somewhere where you didn't have a minus, you had a plus. That's not called confusion. That's just called we just did the steps wrong. Confusion is you don't know how to do this problem at all. That's confusion. When you mess up and do this step and your answer don't come out right, then you just messed up by the addition of a plus sign, which throws the whole problem off, which is understandable. But it's not confusion because you understand the process on the problem. X by itself, yeah, correct.